So the product rule says suppose f and g are both differentiable at x equals a. Okay? We have to assume that the underlying functions are differentiable. That is, we're saying suppose f prime and g prime exist. Okay? That's what does it mean to be differentiable? Why don't you as a student go all the way through till the final exam and say, I don't know what differentiable means. It's easy. It means the derivative exists there. Okay? Sounds like a large, complicated word, but remember that not all functions are differentiable everywhere. You can't always compute the derivatives. Specifically, we've seen at cusps and at corners and at vertical tangent lines, you can't compute derivatives. Okay? So assuming that we can take the derivative of the underlying functions at these locations, what is the derivative of the product of these two functions? How do we compute the derivative of the product of these two functions? Okay? Folks, your initial gut is not going to work here. You cannot distribute the derivative over the product. Everyone, let's say that together. You cannot distribute the derivative over the product. You might, anyway, even though you just said it. You can't. Okay? So how do we take the derivative of a product? Well, the product rule, which we'll prove in a different video, says you take the first times the derivative of the second plus the second function times the derivative of the first. Folks, if you've had some calculus before, you might have memorized this in a different order. That's okay. You might memorize it by a different little string of expressions. That's okay. For those of you that are new, though, I ask you to learn it this way. We say that you take the first, this is the first here, times the derivative of the second. We got the operation plus, watch that. And then what do? We take the second, and then we multiply that to the derivative of the first. So you'll want to memorize that. Okay? There's an easier way to remember that. You say you multiply each with the other's derivative. I've just linked the 3 blue, 1 brown video where he goes through a nice visual interpretation of the product rule. Highly recommend you take a look at that. Okay? But as far as what do you need to memorize? Some variation of this expression here. Okay? So we summarize this by saying the first times the derivative of the second plus the second times the derivative of the first. Okay? So let's do number 6 together. So we need to identify two separate functions here. Let's identify the first function. What's the left product, the left factor in this product?
E to the power of x.
E to the x. What's the right factor in this product? Okay. Folks, if you make mistakes, go back to what I'm doing in this video right here. To be honest, come class tomorrow, I will just start doing the product rule. I'll just start writing it out. Okay? But for right now, let's practice actually following this formula. We would say that h prime of x is equal to, we said the first function, which I'll write as f of x, times the derivative of the second function. Oof, I don't know if I can do all this switching. G prime of x plus the second function times the derivative of the first function. Okay? I've given myself a nice little roadmap. You do not have to actually write this part out like this, but I think it's helpful as you first learn the rules. Okay? So let's see here. We've got the first function, which was e to the x, times, and I'm gonna be a little bit pedantic here, folks, just to practice using this notation. Okay? If you don't like what I'm writing on the board right now, ask yourself, is it because you're worried about running out of pencil lead, or because you're still not completely comfortable with this notation? If it's because you're not completely comfortable with this notation, well, let's keep writing it out. Okay? Plus, so let's see here, we've got g of x, which is x to the fourth, times, by Leibniz's notation, we're going to take times the derivative of e to the x. Does everyone see what I just wrote there? Okay. I oftentimes, when these problems get large, use Leibniz's notation to sort of take a breath. Okay? I might be in the middle of computing a very large derivative, and I just get to a particular component that I'm not ready to take the derivative yet. So I just pause and I say, in a moment, we'll take the derivative of e to the x. Okay? If you feel comfortable doing it right away, go ahead and do so. But this is just sort of a nice bookkeeping procedure. All right, here we go. We get e to the x times 4x cubed plus x to the fourth times e to the x. We'll just park our answer there. All right, folks. Warning. I don't use exclamation marks lightly. All right? So there's one of them. So take heed, because I see this all the time. The derivative of the product is not the product of the derivatives. Okay? So here you get to see Thorsten's error. Okay? And then I'll have you explain the mistake and fill it out. I'd like you to go ahead and do that on your own time. We're going to move on to the quotient rule next. So I'm going to get through the quotient rule and then turn you guys loose on the in-class work. So I'll let you guys work through 8 and 9 after class. All right. Now let's look at number 10, the quotient rule. Okay. The quotient rule says, suppose that both f and g are what? What are we going to suppose? What do you think? We're going to suppose that they are both differentiable. At x equals a. That is, suppose who exists? Yeah, f prime and g prime exist. Then the derivative of the quotient. What's a quotient, folks? It's one function, or one expression, in this case one function, divided by another. Okay, here we go. This is our formula for the quotient rule. Okay. It will be the bottom function times the derivative of the top function minus the top function times the derivative of the bottom function all over the bottom function squared. For those of you that are curious where this one comes from, I will derive this in a video that you can watch in the post work. Okay, I'll actually come up with this rule using the limit definition. But really, if you've got the product rule, what can you do with this g of x? You could rewrite it as g of x to the negative 1 power. And once you've learned a few other rules, we could go ahead and just do the product rule on it and then clean it up. Okay, so that's a nice way to see where this one comes from. We'll talk about that in a couple sections. Okay? For right now, we've got a large, complicated formula. Okay? Oftentimes what we'll do is we'll abbreviate this just using the prime notation. We'll write g f prime minus f g prime all over g squared. That just makes it a little bit easier on the eyes. So here's a little ditty to remember this by. The bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. Folks, there's other little ditties out there. I'm not really a big fan of ditties. Okay? Some people say you call this the low one, and you call this one the high one, and then you could say low d high minus high d low, square the low, and there you go. Okay? I find that so hard to remember that I would rather just memorize the stinking quotient rule. But whatever works for you, okay? You have to know this. All right, let's do this problem. Okay? Just like before, we've got an upper function and a lower function. We've got two functions in this expression. Let's call f of x e to the x. And we'll call g of x x to the fourth. So then our quotient rule says that m prime of x, the derivative of the quotient of these two functions, is the bottom function times the derivative of the top I think I just wrote that. We'll put f prime there. Minus the top function times the derivative of the bottom function. Careful, don't forget that derivative mark on the bottom function. All over the bottom function squared. Folks, quick word of warning. Some people aren't really careful about memorizing the product rule, and they don't memorize it in the exact order I give it to them. That's fine because of the operations that go within the product rule. You got some addition, you got some multiplication, both of which commute very nicely. With division and subtraction, those do not commute well. So does the order matter on all of this? Absolutely. Okay. All right. So let's go ahead and start plugging in what we know. And we'll just put it all in one color. Here's the bottom function, which is x to the fourth, times the derivative of e to the x. What's the derivative of e to the x, folks? E to the x. Minus, right? Minus what?
E to the x.
Yeah, minus the e to the x, the top function, times the derivative of the bottom function. What's the derivative of that bottom function?
3x, or 4x to the power of 3.
4x cubed by the power rule. All over e to the x squared. Okay. Careful, folks. How else could I write e
to the fourth squared? It's not.
Oh, it's x to the fourth power. Thank you, thank you, thank you. I got my bottoms and tops mixed up. X to the fourth squared. Folks, what's x to the fourth squared? X to the eighth. Was that real hard to fix? No, be polite and clean that up. Okay. Careful though, what if I had e to the x squared? What if that had been my bottom? What is e to the x squared? How else could I write that?
E to the 2x.
Yeah, be careful with your properties of exponents. My math lab might say that's the answer. They might say this is the answer right here, and you say, well, this is what I got. Are you both right? Yes. This is the nicer way to put it. Okay. Questions on that? Okay. So that's the quotient rule. Okay. So again, I give you this statement here: the derivative of the quotient is not the quotient of the derivatives. That shouldn't surprise you. If multiplication doesn't work, then absolutely division won't work. Okay. Here you get a nice example of somebody's this is the classic mistake. I see this all the time, right? The top function is x to the sixth. The bottom function is the square root of x. And somebody just takes the derivative of the top over the derivative of the bottom. They forgot all about the quotient rule. They thought they could distribute the derivative over the quotient. So I'll let you guys go ahead and finish up this handout on your own time. Okay. And now I want you to go ahead and jump into the in-class work.